Venus is the second planet from the Sun and is often referred to as Earth's sister planet due to their similar size and composition. However, Venus is a much harsher environment than Earth, with surface temperatures hot enough to melt lead and an atmosphere thick with toxic gases. So if you're interested in the mysteries of Venus and the search for extraterrestrial life, be sure to watch our video in its entirety. Venus. Venus is the second planet from the Sun and is Earth's closest planetary neighbor. It's one of the four inner, terrestrial, or rocky planets, and it's often called Earth's twin because it's similar in size and density. These are not identical twins, however. There are radical differences between the two worlds. Venus has a thick, toxic atmosphere filled with carbon dioxide, and it's perpetually shrouded in thick, yellowish clouds of sulfuric acid that trap heat, causing a runaway greenhouse effect. It's the hottest planet in our solar system, even though Mercury is closer to the Sun. Surface temperatures on Venus are about 900 degrees Fahrenheit, 475 degrees Celsius, hot enough to melt lead. The surface is a rusty color, and it's peppered with intensely crunched mountains and thousands of large volcanoes. Scientists think it's possible some volcanoes are still active. Venus has crushing air pressure at its surface, more than 90 times that of Earth, similar to the pressure you'd encounter a mile below the ocean on Earth. Another big difference from Earth, Venus rotates on its axis backward, compared to most of the other planets in the solar system. This means that on Venus, the Sun rises in the west and sets in the east, opposite to what we experience on Earth. It's not the only planet in our solar system with such an oddball rotation. Uranus spins on its side. Venus was the first planet to be explored by a spacecraft. NASA's Mariner 2 successfully flew by and scanned the cloud-covered world on December 14, 1962. Since then, numerous spacecraft from the US and other space agencies have explored Venus, including NASA's Magellan, which mapped the planet's surface with radar. Soviet spacecraft made the most successful landings on the surface of Venus to date, but they didn't survive long due to the extreme heat and crushing pressure. An American probe, one of NASA's Pioneer Venus multiprobes, survived for about an hour after impacting the surface in 1978. More recent Venus missions include ESA's Venus Express, which orbited from 2006 until 2016, and Japan's Akatsuki Venus Climate Orbiter, orbiting since 2016. NASA's Parker Solar Probe has made multiple flybys of Venus. On February 9, 2022, NASA announced the spacecraft had captured its first visible light images of the surface of Venus from space during its February 2021 flyby. Life on Venus? New updates on the search. You can find the molecule phosphine in some interesting places: insecticides, penguin tummies, and possibly the clouds of Venus. Phosphine can be a byproduct of living things, so finding it in Venus clouds could possibly indicate something alive floating around the planet. Venus' surface is inhospitable, but there are regions in the cloud decks where temperatures and pressures are similar to those found on Earth. Astronomer and astrobiologist Jane Greaves led the team that announced the discovery of phosphine in the Venusian atmosphere in 2020. She began including a picture of a penguin in her talks to illustrate one of the places you can find phosphine, and it caught on as a meme. "I'm afraid we did confuse people, rather with this penguin idea," she said during an American Astronomical Society (AAS) meeting presentation in June. "We did not, in fact, suggest there are penguins flying desperately, flapping above the surface of Venus. What she does suggest is that there is solid evidence for phosphine in the Venusian clouds." In the 2 years since her original phosphine paper garnered great interest from the public and scientific community, many other scientists studied the paper and did their own research. Some scientists supported, while others questioned the validity of the detection of phosphine. In her AAS talk, Greaves outlined the story thus far and presented new findings in support of her phosphine in the clouds of Venus. Do you like this video so far? And don't you want to miss anything about this subject? then please subscribe to this channel. Thank you. Why is it so hard to detect phosphine? Venus is the brightest object in the sky after the Sun and the Moon. Searching for a faint signal like phosphine is like looking for a firefly in front of the Sun. This caused a brief snag for the original phosphine findings. The AMA data had to be recalibrated because the telescope is not used to looking at such bright objects. Complicating things further is the fact that Venus and Earth are always moving with respect to each other, creating Doppler shifts in the signal that must be filtered out. Only with careful data processing does a phosphine signal emerge, and scientists must be cautious to verify that what they're seeing is real. Greaves is working on a simpler way to crunch her observation data using a mathematical technique called a Fourier transform. She hopes the process will reduce user bias and make it easier for others to replicate her work. Another potential issue is that some molecules, like sulfur dioxide, have signals that look a lot like phosphine. Greaves and her team have reanalyzed their data and found that although sulfur dioxide could amplify a phosphine signal, the effect would be small compared to what they actually observed. No phosphine on Venus, according to Sophia. Venus is considered Earth's twin in many ways, but thanks to the Stratospheric Observatory for Infrared Astronomy, SOFIA, one difference now seems clearer. Unlike Earth, Venus does not have any obvious phosphine. Phosphine is a gas found in Earth's atmosphere, but the announcement of phosphine discovered above Venus's clouds made headlines in 2020. The reason was its potential as a biomarker. In other words, phosphine could be an indicator of life. Though common in the atmospheres of gas planets like Jupiter and Saturn, phosphine on Earth is associated with biology. Here, it's formed by decaying organic matter in bogs, swamps, and marshes. Phosphine is a relatively simple chemical compound. It's just a phosphorus atom with 3 hydrogens, so you would think that would be fairly easy to produce. But on Venus, it's not obvious how it could be made, said Martin Cordner, a researcher in astrochemistry and planetary science at NASA's Goddard Space Flight Center in Greenbelt, Maryland. There may be other potential ways to form phosphine on a rocky planet, like through lightning or volcanic activity. But none of these apply if there simply isn't any phosphine on Venus. And according to Sophia, there isn't. Following the 2020 study, a number of different telescopes conducted follow-up observations to confirm or refute the finding. Cordner and his team followed suit, using Sophia in their search. The recently retired Sophia was a telescope on an airplane, and over the course of 3 flights in November 2021, it looked for hints of phosphine in Venus's sky. Thanks to its operation from Earth's sky, Sophia could perform observations not accessible from ground-based observatories. Its high spectral resolution also enabled it to be sensitive to phosphine at high altitudes in Venus's atmosphere, about 45 to 70 miles, about 75 to 110 kilometers above the ground, the same region as the original finding, with spatial coverage across Venus's entire disk. The researchers didn't see any sign of phosphine. According to their results, if there is any phosphine present in Venus's atmosphere at all, it's a maximum of about 0.8 parts phosphine per billion parts everything else, much smaller than the initial estimate. Pointing Sophia's telescope at Venus was a challenge in and of itself. The window during which Venus could be observed was short, about half an hour after sunset, and the aircraft needed to be in the right place at the right time. Venus also goes through phases similar to the Moon, making it difficult to center the telescope on the planet. Add in its proximity to the Sun in the sky, which the telescope must avoid, and the situation quickly became tense. You don't want sunlight accidentally coming in and shining on your sensitive telescope instruments, Cordner said. The Sun is the last thing you want in the sky when you're doing these kinds of sensitive observations. Despite the fact the group did not find phosphine after the stressful observations, the study was a success. Along with complementary data from other observatories that vary in the depths they probe within Venus's atmosphere, the Sophia results help build the body of evidence against phosphine anywhere in Venus's atmosphere, from its equator to its poles. Sophia was a joint project of NASA and the German Space Agency at DLR. DLR provided the telescope, scheduled aircraft maintenance, and other support for the mission. NASA's Ames Research Center in California's Silicon Valley managed the SOFIA program, science, and mission operations in cooperation with the university's Space Research Association. Headquartered in Columbia, Maryland, and the German SOFIA Institute at the University of Stuttgart, the aircraft was maintained and operated by NASA's Armstrong Flight Research Center Building 703 in Palmdale, California. SOFIA achieved full operational capability in 2014 and concluded its final science flight on September 29, 2022. If you love similar content like this, take a look at my other videos. And if you like it, please smash the like button and make sure you subscribe to the channel and hit the notification bell. If you have further questions, feel free to comment down below. See you in the next video.